today I'm gonna talk about how we use Sonic at RTB House. The previous speaker told that they need user voice, so we are the user voice. And let's start with some thesis that the same goal of provisioning the switches is completely different task if you are hyperscaler, if you have very large company, and when you have a medium-sized company. And we're gonna talk about medium-sized companies because that's our experience, and we wanna inspire the others to embrace Sonic. And when I talk about medium-sized companies, I talk about something like our scale. We have over 100 Cumulus switches in the older part of the network. We have 75 Sonic switches, and this number is only growing pretty rapidly. We use Sonic for over 3 years, and we have 6 network administrators that configure them, and also other network devices like routers, VPNs, root reflectors, and others. So we don't have resources to make super fully automation of the configuration. We have 6 people, but we're also not in the small scale where we can do everything by hand. And we see ourselves in the middle. We still must have the elastic configuration to support the legacy parts, and we want to make something as cheap and simple as possible because we don't have resources to make a very complex solution. And what we need? We need 4 crucial things. The first one is to generate and apply config.db. Second is generate and apply FRR config. Third is installing some custom software that we want, like monitoring, collecting logs. Medicine we use, for example, we have our CLI tools. And the fourth thing, very important, is to have ability to very fast apply changes and making rollbacks. We don't want the downtime for changes that isn't required. And the goal of today is to just inspire others. You can use only parts of our solution, you can use whole. I'm not gonna sell some product, we will share the code on the GitHub, but we want just to inspire others. And what we have tried already. We started at the beginning with simple bash scripts running with loops of config something, config interface, config breakout. And that's something that still exists because it was the most reliable way to configure Sonic, as we can force order of running these commands, because at the beginning, just loading config.db crashes the Sonic. And we still have this as a backup, but Sonic evolves, and now we don't see this problem anymore. But there are problems with this approach because it resets everything, network stops working, then we generate every comment, which takes about 10 minutes. For change that may be enabling one interface, but that doesn't require to reset everything. We can add some, there are ideas to add some Jenkins, Puppet, but this will not change the main problem, only add some features like visibility and templates. There's GNMI or REST API that from the outside sounds the best, but there's a large problem with API. When we call the wrong thing, we can easily crash the Sonic, and then we cannot reset the configuration from the outside because we cut ourselves from the API because it crashes. So that's why we use something else. There's zero-touch provision, and that's something that we use. It's very useful, but it's only for the first provision. So we have made something new, but still simple. Use very, very basic tools. Linux server does it. Some basic knowledge of Python. Git for storing configuration, and I will tell later how we use Git. And there's Jinja for templating. And there are 4 steps that I want to cover. There's setting up of the system, and I will talk about it at the end. There's config generating that will be put on the repo. There's problem of config distribution from the repo to the switches, and of applying it and rolling it back if something breaks. So we done config generation with Python. We took 3 levels of domain-specific configuration that is designed for our needs, as simple as possible. Those 3 levels cover global, that is universal to every switch in every data center. We have data center level that is universal to every switch in a given data center. And there is switch config that is only applied to given switch. We also add to this platform configuration that we took from Sonic image, and templates like template for FRR. Then we build it using Python. This basically translates the domain-specific configuration to the config db.json and frr.conf. But the step of translating may seem complex, but it's not. Okay, so the projects look like that. We have directories for configuration, for templates, for the final list of configurations. But I will go to the next part. That's the key, how we do the translation. That's Python data classes, and they enables us to very easily convert domain-specific configuration to the general use case. So with structures like systruct or Java classes, we have something that will take JSON, will take YAML, parse it automatically to the given model that we wrote, as you'll see the example, fill the missing values, parse the type, and do everything for us. And we just take it and put it into a Jinja template that will generate the config that we want. That's the example for BGP neighbors in FRR. I have more complex samples for route maps and IP prefix lists. I will not show everything. I will not explain how exactly does it work, but you can see that there are loops from Python. That's exactly Python inside those brackets. And you can just with that Python generate some templates, some configurations from templates. And then we go to the distribution part. You can use, of course, Ansible or other tools to distribute. We made that even simpler. We use Git, and we use the feature of remotes. Each switch in our infrastructure has its own remote, and each remote has 3 URLs. one to the global repository, the first one. If there's a conflict or something else, it will break at the beginning. The second one to the repository at the level of data center, that's on the special server there in management network. And the third one is the switch itself. That's resolved the issue of zero-touch provision that just during provision clears from the second server to the switch. And because we use Git, we have Git hooks. And we can use Git hooks to make applying and rollbacks pretty easily. We will put that hooks inside the same repo as configuration. And we came to the next problem of applying this configuration. Basically, there are two methods, config reload, config load. Config reload removes everything from database and loads it from beginning, but that takes time and causes downtime. We don't want to do that. And there's config loads, but there's a problem because it needs patches. If you just remove something from your config and do config apply, config load, then the command will not see it because it takes only patches. So we created a simple tool that we will share, patch config that just takes two config DB versions and generate patch. And if you reverse arguments, it generates a rollback patch. And with this tool, very simple, you can achieve the goal of applying changes. And that's how our Git hook looks like. We have very simple logic that when you push something to the switch, then the patch config runs, you get two patches. First, you apply the patch with changes. You sleep, for example, 60 seconds to see if everything is okay. We check if number of BGP neighbors dropped, if status of Sonic is healthy. If not, then we they do the same config load rollback. Then we check again. If there, then it should work because you have done some changes that break it. But if it's still not working, then we do the full reload of the old config file. And that's the demo. I have shortened the sleeping part to not waste time. In this demo, you will see just disabling one interface, 44. That was the domain-specific configuration that we use. Now we're building the final configuration, and we'll push it to the switch. The remote is named just as a switch. For convenience, the hook prints in colors the changes that are in configuration. You can see that there's just removing the parts of the interface. As I said, I have shortened the part of waiting, so no, that's just all configure applied. Okay, so now because I have time, I go to the system setup. We start with zero-touch provision. DHCP points to the configuration inside the system repo that we have. And the ZTP script just run the directory jobs, where we put every script that needs to create a working switch. It installs all the software, installs Puppet, monitorings, and it initializes the configuration repo that I talked earlier. But there's more interesting part about upgrading Sonic, because we have some problem with Puppet that runs pretty long time in the data centers with high ping from the Puppet server, and it makes the switch very long upgrading after reboot. So I have extended the Sonic installer that installs the Sonic inside Harroot. And our extension just puts our scripts, our running jobs inside the Harroot. So at the end of the script, we will get the fully functional our installation of Sonic, while the previous one is still running and fully operational. We also add some nice features like copying SSH keys, so we don't have to accept it every upgrade. And after reboot, that switch will be ready in 2 minutes, because it doesn't need to do anything else than reboot. All the source code, it will be uploaded to this organization. And thank you. That's all from me. Any questions?
Don't look at me. Thank you.
What version, what Sonic has to build using?
Now we use the export.
Export.
Bigger.
Any other? I knew that one, yeah, so.
A lot of questions, but after that.
Okay. Thank you. Thank you, Piotr.